Hello everyone, welcome to my channel. In this video, I'm going to introduce the concepts of always-on availability groups that are central for configuring and managing this type of cluster. At first, I will show you why AG is needed and created, how it functions at high level. Afterwards, we will dive more deeply into the internals of AG and I will show you in a very much detailed way how AG works internally. If you are building, troubleshooting, or trying to understand AG cluster, you find this video very much useful. Let's get started. First, let's discuss about AG cluster at high level. Imagine you have one machine in network A where your database is located. In this case, if there is any outage happens, for example, your network is down or your machine breaks because of some hardware failure, you may lose your data, right? So as a database administrator, you may want to prevent this kind of situation and make your database be available always, even in the case of disaster. I mean, you want disaster recovery solution, right? Also, you may want to make your database highly available to distribute the load among different nodes. Not only one node, I mean, among the different nodes. For example, by creating a read replica. AG gives you this DR solution, I mean disaster recovery solution, and high availability capabilities. Let's create AG cluster for this environment and see how it works. First, along with current network A, we create network B, where we create another node with separate database. Also, we create another node in network A. We call this node 3. After that, we create Windows failover cluster by including these 3 nodes. Finally, we create SQL Server AG cluster on top of the Windows failover cluster by declaring our current node as primary and other 2 nodes as secondary. You can declare any node as primary and any node as secondary, by the way. After creating AG, the primary replica sends transaction log records of each database to every secondary replica and synchronization begins. There are some important points to mention here. They can be multi-subnet, multi-region, and single-subnet AG clusters. You can create any type of AG cluster, okay? Here we created multi-subnet cluster by using network A and network B. In each AG cluster, there can be one primary replica and up to 8 secondary replicas. And finally, data synchronization occurs between the primary database and each connected secondary database, independently of each other databases. For example, if you have database A and database B in node 1, okay, synchronization happens for each database independently. If synchronization breaks down for first database, it does not impact the second database. This is very important point, okay? Therefore, a secondary database can be suspended, fail without affecting other secondary databases. Okay? So, now what about client connections, right? There is a feature resource in AG cluster called listener. An availability group listener is associated with unique DNS, virtual IP address, and TCP port number. By using these, clients can connect to AG cluster. The read-write connection sessions are automatically directed to the primary replica. If you configure secondary read replica, the read connections are also directed automatically to any secondary read replica. We will speak about read replicas in future series. Okay? In short, listener automatically detects who is primary and who is secondary in your cluster and sends connections accordingly. So we have seen how AG cluster is built at high level. Now I'm going to show AG cluster features by using SSMS. I have built a single subnet AG cluster quickly, okay, on my side. If you want also to build the same environment, you can refer to the above link to my another video. Okay, I have built a single subnet because it's easy to build. And if you want multi-subnet cluster, I will leave corresponding documentation on how to build multi-subnet cluster in the video description. Let's check first Windows failover cluster. We know that SQL Server Availability Group AG cluster is built on top of Windows failover cluster, right? So therefore, let's start from Windows failover cluster. For that, we go first to failover cluster manager. Okay. Then we click on our cluster name and expand it. Then we click on nodes. As you can see, I created a Windows failover cluster by using two nodes. Okay. So these nodes are located in network 1. Let's call this network A by comparing to our example, right? This is network A, and in this network A, there are two nodes. We don't have network B because I did not create. If you want, you can create by yourself. So in network A, we have two nodes. I created SQL Server AG cluster by using these two nodes in network A. To check this, we can go, let's do first this one. To check this, we can go to the first primary replica. Okay. To check AG, we just click expand on always on high availability group, expand this, and we can see that our AG name is AG22. Okay. So in this AG, there are two replicas, right? The names, right? So it is matching to the name of the nodes. Okay. So in this AG, only one database is added. This database is being synchronized from primary to secondary. Okay. And clients can connect to this AG replica by using the listener name. To see the properties of the AG, we can also try with dashboard. If you click on show dashboard, you can see the whole information cluster. Two replicas, and one of them primary and second one is secondary. So you can see that they are synchronous-commit. We will discuss about this later. So failover mode, automatic, we will also discuss later, and we can see that both of them are synchronized state. It means databases are being synchronized and they are available in two nodes. What database? You can see from here, SalesDB database. Okay, this is a dashboard of AG replica. You can see the properties of each replica by clicking on the properties. Okay, you can see that instance name here, it's equal VM1, it is secondary, synchronous-commit, automatic, okay, and the session timeout is 10 seconds. The session timeout period is an availability replica property that determines how long connection with another availability replica can remain inactive before the connection is closed. Okay? The primary and secondary replicas ping each other to signal that they are still active. Receiving a ping from the other replica during the timeout period indicates that the connection is still open and that server instances are communicating. On receiving a ping, an availability replica resets its session timeout counter on that connection. Okay. This session timeout period prevents either replica from waiting indefinitely to receive a ping from the other replica. If no ping is received from other replica within this session timeout period, the replica times out. So therefore, this is also one of the important metric we should take into consideration. And endpoint URL is the URL to which another replica is connecting to this replica. For example, we call this secondary replica, right? Another primary replica connecting to this and synchronizing data by connecting to this endpoint URL with port 5022. Okay, so this is high-level overview of AG replica. So we understood that the database are synchronized among the replicas. In this point, I should also mention about synchronization modes. The synchronization mode determines whether the primary replica waits to commit transactions on database until a given secondary replica has written transaction log records to disk. There are two modes of synchronization in AG cluster, asynchronous and synchronous. Let's discuss about asynchronous first. Under asynchronous-commit mode, the primary replica commits transactions without waiting for acknowledgement from asynchronous-commit secondary replica. Okay? For example, let's set node 2 as a synchronous replica. Suppose a client connected to listener did some update statements there, okay, and commits transaction. What primary replica does in this case is it first records this transaction to transaction logs locally here. Then sends these transaction logs also to a synchronous secondary replica, okay? Then it does not wait, please pay attention here, it does not wait for confirmation about whether this replica, secondary replica, received and also flashed the transaction logs to disk. Without waiting, the primary replica responds to client about the success of the commit. In short, we call asynchronous mode as send and forget. Do not wait. Okay? Next, let's switch to synchronous commit mode. Synchronous commit mode, on the other hand, waits for synchronous commit secondary replica to acknowledge that it has finished flashing the log to disk. For example, if we set node 3 as synchronous replica, every time primary replica waits for node 3 to commit transaction logs to disk before reporting back to client about the success of transaction commit. Okay, you may ask, when do we need synchronous and when do we need asynchronous commit mode? Asynchronous commit mode is used when waiting is costly. We use asynchronous commit mode for disaster recovery solution, for example, where our secondary is located in long distance from primary, for example, in separate network. In this case, we know that there is high latency, right? For example, node 2 in our case. Synchronous commit mode, on the other hand, is used for short distance replicas for high availability solution. For example, node 3 here. Okay, so until here, we talked about AG at high level, right? We talked about primary and secondary replicas. Also, we talked about how synchronization works among replicas and how you can utilize AG for DR and high availability cases. Now, let's switch from high level overview to more detailed view of AG by diving deeper into the internals of AG. Suppose we have AG cluster with two nodes. Client is connecting to listener name and committed update transaction. The request goes to primary replica's CMD parser automatically, where the query is checked for syntax mistakes. After the parsing and binding, the hash of the query is generated, and that hash is checked against the plan cache in the buffer pool. Why? We should determine whether a suitable execution plan already exists for this query, okay? You can ask, what is execution plan? Execution plan is a series of instructions to execute a query in the most efficient way. Okay, in other words, it is the optimal plan to execute the query. Once the SQL Server generates a plan for the first time, it saves the plan in the plan cache in memory so that it does not generate the one again when the same query is run in the server. So if the plan cache exists, it is passed to query executor component in the next stage to execute it, actually. Okay, what is a query executor? Query executor, as name indicates, executes a query plan, going through each step in the plan connecting with the storage. Okay, what if there is no plan, right? We made hypotheses like there is plan in the cache, but what if there is no plan in the cache? The plan in the cache might not exist since the query might be being run for the first time, or the plan might have been deleted from the memory. In this case, SQL Server generates a plan newly in the component called optimizer. It is here, located here. And then after generating the plan in optimizer, it is just passed to the query executor. That's all. Okay, there is nothing so much so much difficult here. Okay, after getting the plan, how does the query executor execute the query? For this, it first connects to access methods component. This component is the interface through which data is retrieved and modified. Okay. Before any change to the data, for example, here we are running update query, right? SQL Server follows write-ahead logging and logs this data change in transaction log first by connecting to transaction manager. Okay, transaction manager is responsible for any change in transaction logs. In other words, data change query, for example, right? When data change, for example, update query comes to access methods goes to transaction manager. When transaction manager gets this kind of update queries, right? It first caches a log in log cache. Then this cache is flushed to disk. Then log cache is pushed to log pool to send secondary replica, and from log pool, logs for each database is captured and sent to the corresponding partner replica. Okay. This capture process runs continuously as long as the availability replica is connected and data movement is not suspended for any reason. Finally, the message in each database replica is sent across the wire to the respective secondary replica. Okay, so we have only one replica here, so primary has only one queue and sends the data through this queue only. If we have two replica, for example, we might have two queue and data is sent to each queue by separate threads. After getting this data, secondary replica caches and flushes the logs to disk. After the log flush, okay, the acknowledgement is sent back to the primary replica, to the transaction manager. Transaction manager sends this acknowledgement back to access methods. Okay, now the whole synchronization between replicas finished from this point. Okay, this is happening. Please pay attention. This is happening in milliseconds. Okay, within milliseconds, this kind of process is happening for each query you run against the AG replica. After getting the log record confirmation, access methods firstly submits a related request message to buffer manager. We change the data in the buffer pool. Again, important point is buffer manager does not change the data in this directly, but only change the data in buffer pool, in the memory. If the page is not in the memory, buffer manager does not bring the data from this directly. Instead, buffer manager gets the page from the database on disk, puts it in the data cache, and passes the result to access methods. Okay. Then access method sends confirmation back to the client in this way, like going through each way, okay, each component. One important point also here, in the secondary replica, you might, like after the lock is hardened to disk, reduced threads, there are reduced threads, which applies with these logs, transaction logs to disk, okay? This is a background progress. Furthermore, you may ask a question, is there a difference between asynchronous and synchronous mode, which we talked about, right? Yes. In the case of asynchronous mode, we understand that primary replica does not wait for the acknowledgement from secondary replica, right? Therefore, after the step number 7, the acknowledgement is sent back to transaction manager immediately and ultimately to the client, okay? The steps from 8 to 14 are made in the background asynchronously, okay? If your replica is not asynchronous but synchronous only, the whole process is repeated every time you pass some kind of change, update, insert, delete queries, okay? So we understand the whole query execution flow in AG cluster and how AG works internally. We understand how AG works now, and we know that there is one primary replica with up to 8 secondary replicas, right? You can create. Data is synchronized among these replicas for disaster recovery purposes. Disaster can be, for example, the primary node may go down suddenly, or the whole network of primary site can go down unexpectedly. So how AG responds in these situations? There is a concept in AG cluster called failover. During failover, the target secondary replica transitions to primary role, becoming the new primary replica. For example, in our case, suppose there is an outage happened with node 1 and failover happened to node 3. As a result, node 3 becomes primary after failover, and this new primary replica brings its database online as a primary database, and clients are automatically directed to this new primary replica if you have listener, right? So what about the previous primary replica? In this case, I mean node 1. When node 1 comes online after an outage is fixed, it becomes a new secondary automatically. It will just scan the cluster and it understands that there is a new primary replica, so it automatically transitions to a secondary replica, okay? It is designed in this way. Now, about failover we are talking about, and I want to mention also one important point. There are 3 forms of failover: automatic, manual, and forced with possible data loss, okay? You can set automatic and manual failovers with synchronous secondary replica, while you can do all the forced manual failover with possible data loss in asynchronous secondary replica. Okay, rather than speaking many things, let me explain each type of these failovers by simulating maybe some kind of outage in SSMS, okay? Okay, let's first speak about automatic failover. I have a G cluster, as you can see here, with 2 nodes, SQL VM1 and SQL VM2, okay? And the SQL VM1 is primary, and SQL VM2 is the secondary replica of the same AG cluster. Now, if we look at the properties of this AG cluster, we can see that failover mode here for each replica instance. We already spoke about synchronous-commit mode, right? Synchronous, it means the primary replica should wait secondary replica every time the client commits some kind of transaction, right? So synchronous-commit, we understand this kind of configurations. You can just set it from here, asynchronous and synchronous, okay? So Failover mode, on the other hand, it is here. Now, as you can see, I have synchronous automatic failover mode. Okay. What does this mean is when there is something goes wrong with primary side, with primary replica, automatic failover happens and SQL VM2 becomes primary replica automatically. Okay. So let's try to simulate this kind of outage with primary replica. Okay, so this setting we have, click OK. So I will just switch this replica off. I mean, I will stop this. I will just stop this replica. Okay, so this will simulate the outage, right? So I will just click yes. Okay, now my primary side node is stopping. Okay, imagine there's something goes wrong and it is stopping. Now the automatic failover should happen. Let's check. So close this, and if we update here, refresh the groups, and as you can see now automatically this SQL VM2 became primary. Okay, so automatic failover happened. This is how automatic failover works. We can just go and see the properties of this. As you can see, now this is primary. Okay, let's see the dashboard, how it goes. So in the dashboard, okay, as you can see, there's something wrong with primary, previous primary, I mean. So it is not synchronizing, there's something wrong. As a result, the second one became primary. Okay, this is automatic failover. Now let's try to start this again. Start. Okay, yes. And after this, we'll refresh. And we will go to here. And here you can see that this previous primary became secondary automatically. Okay, it just realized that there is primary already, so it just transitions to secondary automatically. Now let's do manual failover. Okay, let's see manual failover. As we can see that our primary was SQL VM1 before, right? Let's fail back with manual failover. We will just click on it and click failover and start manual failover. Okay, we will just click OK. We click connect, and do finish. Now we are doing manual failover. You see, check and close OK. Now, as you can see, this has become secondary and this has become primary as before. Okay, this is how manual failover works. If you go there, properties, and makes this automatic to manual failover, for example, right? Manual failover, and click OK, automatic failover does not happen. Okay, even if we switch off this, even if we stop this, automatic failover does not happen. Okay, this is how automatic and manual failover works. Okay, I hope you understood all of the points. Now let's try to do with forced manual failover. Forced manual failover, as I told you already, it works with asynchronous mode. Okay, asynchronous. We will do this asynchronous. Okay. Okay, so we cannot choose automatic with asynchronous, please. It gives error. Okay, if we do automatic, if we click OK, it saves. Asynchronous-commit availability mode does not support automatic failover. Okay, for automatic failover, use synchronous-commit. This is important point. So therefore, we just choose manual only and manual, and click OK. Now let's try to do forced manual failover with possible data loss. Okay, we'll click on failover. I'm sorry, I think we should again to reconnect. Let's do reconnection, failover. Maybe we should try from here. I think there's some kind of connection issue. Yep, and we will do this. And here you can see data loss warning, right? Data loss warning. It is saying the replica has one or more data that are not synchronized. It means it is asynchronous. It is synchronization happening. So therefore, you might incur some kind of data loss. Okay. So therefore, we call this forced manual failover with possible data loss. Okay. So we just ignore this and click next and click here with possible data loss. We just click OK and we just do this. Okay. Finish. Now, if we check, close, if we can see that secondary side became primary. Okay, this is how secondary. Which is how that manual failover with possible data loss works. To summarize, we learned a G cluster at high level and also in depth. If you find this video useful, please do not forget to subscribe to follow my future videos. Thank you for your time.